In this video, I'll be covering question 4, part C from the 2023 AP Calculus AB free response, no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see my other solutions, please check out my other videos. Okay, so remember, the first thing you always want to do when you see a graph on an AP Calc test is make sure you know what this is the graph of. So looking up top here, we can see very clearly that this is the graph of f prime. This is the graph of our derivative. From there, we now need to come down and determine this limit that they're giving us right here. So we start off and we say the limit as x approaches 2 of 6 times f of x minus 3x over x squared minus 5x plus 6. I would tell you to kind of go ahead and plug these values in and see what you get, right? That's always option 1. So you'd say this is 6 and then f of 2 minus 3 times 2, and that would be all over taking 2 and plugging it in on the bottom here. Oops, not a 5x, that would be a 5 times 2. And then plus 6. So out of here, what you would get on the top is you would get 6. And then they told us what f of 2 is in the language of the problem. That is 1. Minus, on top we get 6. On the bottom here, we would get 4 minus 10 plus 6. So out of there, we get 0 over 0. Bells and whistles should be going off. This is what's called an indeterminate form. I'm just calling it an IDF up in there. But when we talk about indeterminate forms, there are two forms to be on the lookout for. One is 0 over 0. The other is infinity over infinity. And when you hit those indeterminate forms, bells and whistles should be going off that you want to be applying L'Hopital's rule. I'm not going to spell out L'Hopital's. You can look that up if you want to, but this is L'Hopital's rule. As soon as we see this up here, in order to earn our points on this, I find it a little bit ridiculous that that work there doesn't give them what they want to show the indeterminate form, but I'm not a grader, so we're going to make sure you get your points. When you know it's an indeterminate form, and you know then that you want to apply L'Hopital's rule, what they want you to do is now break this out into two separate little limit problems and find the exact same thing that you just found from the previous one. So 6 times f of 2 minus 3, and then, oops, I'm not plugging in 2's yet. We're going 6 times f of 6 minus 3x. They want us to find that answer out separately, and then they want us to look at the bottom separately and say limit as x approaches 2 of x squared minus 5x plus 6. Why our first work doesn't count, again, I don't know. But what we would do is basically the exact same thing we just did up at the top to find that we had an indeterminate form. We're going to go and just plug 2 into the equation everywhere we see an x. So we would get 6 times f of 2 minus 3 times 2, which we said f of 2, again, we got out from the language of the problem. So that was 6 times 1 minus 6. That gives us 0. On the bottom then, we're also going to go ahead and plug this in. And now we get out 2 squared minus 5 times 2 plus 6. That's going to get us 4 minus 10 plus 6, which also gives us 0. Then what they want you to do after you've done that, so that's actually 1 point right there for breaking this thing up, is now they want you to come back and basically say what we did up at the top already, which is that this limit, x squared minus 5x plus 6, that does equal 0 over 0, which is an indeterminate form. And then they want you to say, and because of that, and so L'Hopital's, that's where you got to actually spell it out. L'Hopital's, L'Hospital's rule applies. So we've now checked off all the boxes to allow us to go ahead and apply L'Hopital's rule. And let's talk real quick about what L'Hopital's rule says. L'Hopital's rule says the limit as x approaches some number a of our f of x equation over our g of x equation, if that equals one of our indeterminate forms, then the limit of that is also equal to the limit of the derivatives of those pieces. So now what you're going to do is you're going to come back through this problem and you're going to start putting those derivatives into place. So we would say here, you would kind of want to give them the full statement so that they know you're making all the connections, right? We would start off and we would start with our original limit. So the limit as x approaches 2 of 6f of x minus 3f of x over x squared minus 5x plus 6. This is going to equal, and now we're going to take the limits of these pieces. You're never going to do a quotient rule here. You're always just going to think about it as a top limit or a top derivative and a bottom derivative. So on the top, I would get 6, and the derivative of f of x, that would just be a notation game. That would be f prime of x. Then the derivative of negative 3x would just be negative 3 following our power rule. On the bottom, we just have a big power rule that we're looking at. So the derivative of x squared would be 2x. The derivative of negative 5x would be negative 5. And then the 6 goes away. At this point, we can now come back and we start plugging our value in again. So we would come in and we would say, all right, well, this is going to equal, plug in our numbers. This is going to equal 6 times f prime of 2 minus 3 over 2, plugging in for x, 2 on the bottom, minus 5. And so as we do this, now we got to break down our pieces. So this would be 6 times, and that piece right there, f prime of 2 is wanting to know what is the slope at x equals 2, or more importantly, because we have the graph of f prime of x, f prime of 2 is just going to equal the y value off of our graph up above here. So at 2, we can see that we have the point 0. That tells us that f prime of 2 would equal 0, which means we can plug 0 into our equation down below here, minus 3, and on the bottom we end up with 4 minus 5. Cleaning that all up, you get 6 times 0 is 0. 0 minus 3 gets you negative 3. On the bottom, you get 4 minus 5 is negative 1. And in the end, you get out 3 for your final answer. This would have been a 3-point question here. Again, they would have wanted you to show them these two limits individually. That would have been 1 point right there. Then applying L'Hopital's rule, telling them that you can use L'Hopital's rule, and then applying it would have been sort of 1 point between these two pieces. And then you would have gotten 1 point out for the final answer. So 3 points for the whole thing, and you're done. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.